My name is Dr. Paul Mason, and I'm going to speak a little bit about the definition of the planet as the ancient people might have thought of it as a definition. And so that's very different than how we view a planet, and we need to think about that a little bit in terms of putting that into context. And so the definition of a planet was a planet is one of the 5 star-like wandering objects in the sky that move among the stars. So they're objects that look like stars, they move among the stars. So unlike most of the objects they saw, what they call the fixed stars, they were fixed in constellations. The constellations would rise and set, and the stars would go across the sky every day as the Earth spins, and they didn't know that the Earth spins, but they saw that there were these other objects that they called Mars, Venus, Mercury, Jupiter, and Saturn that moved among the stars, various brightnesses. Venus is the brightest, Jupiter would be the second brightest, Mars can be very bright at times. And they found these moving around the sky and said, well, these were special. They had very complex motions, and sometimes moving backwards, which is called retrograde motion. And so the ancient definition of a planet is simply one of these 5 objects moving among others, fixed stars in the sky. Now I'd like to talk about some ancient astronomers that had great success in scientific discovery that they weren't always appreciated at the time or for quite a while, because Ptolemy's and Aristotle's work dominated the ideas for a long time. However, Aristarchus estimated the relative sizes of the sun and the moon, and here's an original drawing of the sun, moon, and the earth during an eclipse, which he also studied. This is a diagram showing the simple idea that he used, and that is that if the moon was some distance from the earth and the sun was some distance further from the earth, then the time that it takes for the moon to go through its phases would be a little bit different. Specifically, the time taken to go 1/4 of the way around the earth, the moon going 1/4 of the way around the earth from new moon to first quarter, would actually be sooner than a 25% of the orbit, because when you get to 25% of the orbit, this is the situation. The earth is looking out at the moon here, but the moon is being illuminated like this, and so kind of a gibbous phase is seen. So the actual quarter moon would be seen a little bit earlier than that, and the similar effect happens at the third quarter moon. And so from that, he was able to use the geometry in these angles here, angle theta, that he could determine by measuring how long it took to go from the first quarter moon to third quarter compared to third quarter to first quarter, because it takes a less time to go from third to first quarter because of this effect. And so his result was that the moon was much closer than the sun. It wasn't exactly right, it was off by a kind of a large amount, but his method was good, and he was the person that we consider to be the originator of the heliocentric model of the universe, where the Earth and the planets are orbiting around the sun. Another ancient astronomer, Eratosthenes, discovered the fact that the Earth is a sphere and measured the size of the Earth. And he did it this way. He had heard that that from where he's at in Alexandria, the sun would not shine down the bottom of a well on the summer solstice, but a little ways away, a place called Aswan today, Syene is what it was called at that time, the sun would shine directly down to the very bottom of a well on the first day of summer, which would be, say, June 21st. And that's the summer solstice. And so on that day, the sun would shine directly down. But if you instead put a pole here in Alexandria, you would see that there would be a shadow that would be cast about 7 degrees. And a well here in Alexandria would not have the light shining down to the bottom. And it's because the Earth is round, and furthermore, Eratosthenes was able to have someone measure the distance by probably a runner to go and measure the distance from Alexandria to Syene. And in terms of the stadia that was probably the one used in the Olympics in ancient Greece, it was 5,000 of those was the distance between Alexandria and Syene, and from that, the records indicate that they probably measured the circumference of the Earth to within at least a few percent. And so this was a very important discovery and a very useful piece of science, because this did show that the Earth was indeed a sphere, and how big it was, in fact, a long time before the Columbus and other travelers among the oceans. And so the Eratosthenes was a very important person in terms of the working of science in ancient Greece. And then finally, Hipparchus. Hipparchus discovered a phenomenon called precession. As the Earth spins, it wobbles like a top. And so it spins once every 23 hours, 56 minutes, but it wobbles like a top, taking the axis of rotation around slowly across the sky, taking 26,000 years to complete one wobble. And it's very similar to if you view a spinning top, like a toy top. At first it spins very fast and straight, but after a little time it begins to precess, which means it has a slow wobble this way around before it falls down. So it has the spin as well as the wobble. And so Hipparchus, what he did was he checked into books that had been written already a couple of hundred years before his time, and found that the star Spica had moved 2 degrees from the positions that they had quoted. And so he then also compared the lengths of the time it takes for the sun to return to the equinox position. That means basically measuring from the first day of spring to the first day of spring again was not the same as the time it took the sun to return back to a fixed star in position. And they were very close, but not exactly the same. And the equinoxes were moving. That indicated that this precession was taking place, and the rate of precession was at least 1 degree per century. And we don't really know what he thought about how or why this is happening, but we now know this is due to the wobble motion of the Earth like a spinning top. He also had a catalog of about 800 stars, and from that we can see that the phenomenon of precession it continues today, and in fact precession is something that always needs to be taken into account whenever making observations of any astronomical object, because I always have to recognize where the star is in the sky based on where the Earth is as it's spinning and wobbling in its path around the sun.